is to keep the definite in the definite integral. All right, so I start out with this integral from 0 to 1 of 12x squared times 1 plus 2x cubed raised to the 5th dx. And I say, okay, I'm going to turn this thing entirely into u's. Okay? I'm going to keep my definite integral, I'm going to keep my boundaries. So I do my u substitution. I say, okay, let's let u be the inside stuff. U is going to be 1 plus 2x to the 3rd. I take my derivative, du over dx equals 6x squared. I solve that equation for dx. Exactly the same steps as my regular u substitution. I take that work and I plug it in. So I've got the integral from 0 to 1 of 12x squared times u to the 5th times my dx is equal to du over 6x squared. I look at this, I say, okay, do I have any x's? Yes, I do. I've got to cancel those x squareds. I can simplify the 12 and the 6, and this leaves me with the integral from 0 to 1 of 2u to the 5th du. Now, at this point, you may be ready to take an antiderivative. However, there's something going on here, and it's very subtle and it's very important. Your transformer is not completely transformed. You've gotten rid of all these x's that are shouting at you, x squared, get rid of me. The problem is, the 0 and the 1, those are x boundaries. These are x values. And so right now, the 0 and the 1 are still need to be transformed into u boundaries. So our job now with a definite integral in option 2 is that we have got to change our boundaries. Change bounds from x bounds to u bounds. So here's how we do this. When x is equal to 0, that's our bottom boundary. When x is equal to 0, u is equal to 1 plus 2x cubed. And so when x is equal to 0, u is going to be equal to 1 plus 2 times 0 cubed, which is 1. And when x is equal to 1, that's our top boundary, then u, which is 1 plus 2x cubed, will be 1 plus 2 times 1 cubed. So when x equals 1, then u is going to be equal to 3. So in order to keep the boundaries in there, in order to not do this extra side step of working with an indefinite integral to find the antiderivative, in order to keep the definite in the definite integral, we've got to change those boundaries to u boundaries. So now we can rewrite our integral as the integral from, instead of having x boundaries, we're going to have u boundaries of 1 and 3. Integral from 1 to 3 of 2u to the 5th du. And now our boundaries are also u boundaries. So everything is in terms of u now. Are there any questions about that? Okay, since everything is entirely in terms of u now, we can evaluate this definite integral. We'll add 1 to the power and divide by the new power. evaluate between 1 and 3, those are u values. And so we've got 1/3 times 3 to the 6th minus 1/3 times 1 to the 6th, which just so happens to give us the same exact answer. 729 over 3 minus 1 over 3 is 728. So there are two options. One is completely throw away the boundaries to find your antiderivative, and then plug those x boundaries into your antiderivative that you found using the indefinite integral, or keep the boundaries and change them into u's, and then plug them into your u value. All right, are there any, Jeff?
What's usually done?
It is, you ask 100 mathematicians, you're going to get about 50-50. Actually, you'll probably get about 48, and then you'll have 4 left over who make the mistake of keeping the x boundaries and plugging in the x boundaries into u, and then those are the ones that don't make it quite as far. All right, other questions? Okay, so this wraps up today's class. I will tell you about the homework I'd like you to work on.